It will be like laboratory virtual instrumentation engineering workbench. Okay, engineering workbench. And the main purpose of this lab view, it is the system engineering software for applications that require test, measured and control with rapid access to hardware and data insights. And the major advantage of this LabVIEW software, which is used to measure some of the physical quantities or parameters with by using sensors or actuators, as well as it will validate or verify electronic design concepts, and it will develop a production test system. And this software which is majorly used for wireless communication system. Okay, wireless communication. And one more top advantage is that by using the software, okay, so we can link with hardware. For example, we are having a motor, okay, the machine will be there. Now we are going to process your signals from the machine to your laptop. So by using this LabVIEW software, we can process the signals from hardware to software, okay, with less wires, as well as by using a digital mechanisms we can do it. Okay, so this LabVIEW, it is a graphical programming language, okay, which is a graphical programming language. And the main acronym of LabVIEW will be L stands for laboratory, LAB stands for laboratory, laboratory virtual instrumentation engineering workbench, laboratory virtual instrumentation engineering workbench. This software which is used for to interconnect with hardware as well as the software systems. Okay, the acronym is laboratory virtual instrumentation engineering workbench, and I am using the software for almost 15 years. Okay, and those students are pursuing a PhD as well as undergraduate or postgraduate students, all are familiar in the software. Okay, and this is one of the easiest software which you can learn within a second. Okay, it will be look like graphical, it is a graphical language. Okay, it's not tough, yeah, because all the blocks are available, so we are just creating the block. Okay, but the main problem here, to install the software, okay, it will take almost 2 hours to 3 hours time period to install the software, because the capacity of the software will be 9 GB, maybe 10 GB also. For students, we can download the software for academic purpose at na.com. Okay, in na.com you can download this software. Okay, and in na.com you have to register it as a student, and you can download it. The downloading version, that is nothing but evaluation version, will be applicable for 45 working days. Okay, and then you afterwards also you can extend it. Okay, and see, I will explain how to open the software. Okay, I'm going to my tab, and there it will be LabVIEW. You see here, LabVIEW, this is 32-bit. If it will be a 64-bit also fine. Okay, if you click this window, okay, if you click this window, I can get this dialog box. Okay, this window will be open. Okay, this is the front window. Okay, this is the front icon of this LabVIEW, and the symbol of this LabVIEW will be plus symbol. You see a amplifier symbol. Okay, this symbol will be a plus symbol, LabVIEW 2019. Okay, now how I am going to explain how to open this LabVIEW, how to open, because now I have opened the software, but I am not execute, I am not enter any data now. Okay, now I am going to create a project. So for that, there will be a blank VI. Blank VI means a new window. Okay, blank VI. You click it. If you click it, it will take a seconds of time to open it. Okay, so I can get this window, and now in LabVIEW there are two windows are available. Okay, in LabVIEW there are two windows are available. One is front panel. This is front panel, and this one will be a block diagram. Okay, there are two windows to be opened. One is front panel, another one is block diagram. Now I will tell how to open this front panel. Okay, this is a front panel, and the second one is block diagram. These are the two windows are there, and you want this window. Okay, now I can zoom this window. Okay, now this is the front block diagram. Now I need this front panel and block diagram in both left and right hand side. Means go to window option, then click left and right. If I click this option, I can get two windows in a screen. Okay, two windows in a screen. And the main purpose of this block diagram, okay, here this window, this white color window, call it as, here only you are going to give the input blocks. You are going to create the blocks here. Okay, this is the input block, and this front panel, okay, you see a grid lines. This front panel, call it as a output. Okay, here only you are going to see your output here. Okay, that's what it will be in grid lines. Okay, so this software, it is a evaluation software. That's what it will be coming like this. Now I will explain it. There are different types of icons are there: file, save apps option, and edit option. That I will explain one by one. Okay, now how to create, what are the blocks are there. Okay, so now you see the cursor, my cursor, it will be a plus symbol. You see, it will be a plus symbol. Now I can right click of my mouse. Okay, if I right click my mouse, I can get these functions. These are the functions. Students, are you able to see this window?
Yes, sir.
Yes, sir.
Okay. Okay, so this is my function. Okay, how to open this function? You see my cursor, right click your mouse. Once you right click it, you will get this function. Okay, you will get this function. Now in this function, there are loop statements also be there. Okay, loops means programming loops. That is loop, if else loop, or while loop, do while loop, like that. Like that C or C++ program we can write it. And the array option and the clusters, because this lab view will be applicable for both C and C++. You can write both the programs at a time, and you can interconnect with your MATLAB software or PSpice or any type of software. But all the softwares are not interconnected directly to the hardware. Okay, how to interconnect with the hardware? You need LabVIEW. Okay, if you have LabVIEW, then only we can connect with the hardware and we can get the result. Okay, it will be for monitoring purpose, they will use it. Okay, now here you see, this is a numeric button. There are plus, minus, subtract, all these symbols are there. Okay, now I am going to explain a small arithmetic operation now. Okay, now what I am going to do, right click your mouse, go to numeric option, there I am selecting plus. Okay, you see here, when I take my cursor to the plus symbol, I can get a small blue color, right? Blue color box, and once you select and place it here, if I select it, I can get a hand icon. Okay, and place it. Once I click a left button of your mouse, then immediately that icon, that hand icon, will be disabled. Okay, so this is my arithmetic operation, plus. Okay, now in arithmetic operation, you see there are two pins are there. Okay, there are two pins are available. That pins are represented in orange color. Okay, two pins are available, two are input, and this one, this right hand side will be output. Okay, and when you place this cursor, because you don't know operation of plus, so what you have to do, you just keep your cursor at the top layer, right click it, and see the property, because you want to study what is the name of this plus. Okay, plus means it will be arithmetic operation. It is arithmetic operation and it will be available. This is object properties for that. Okay, so this is plus means arithmetic operation, and when you keep the cursor here, you see there are two inputs are there. Okay, so now what I'm going to create an input. Okay, so go to the place my cursor here, right click it and create constant. Okay, create constant. Understand? So there are two inputs I'm going to create it, and another point, create another constant. Okay, another constant. If you want, you can move it like this also. Okay, two constants which I create. How to create it? That is, keep your cursor at the pin end and right click, you will get this window. And here one more thing. Okay, and the output side I'm going to create, go to create and constant, go to create constant. Okay, then connect it. It's not connecting it because the constant is not considering it. You see here, again I will explain. Keep your cursor at the end of your arithmetic output, create constant. If I create constant, you see I can move this constant, I can't see the wire. Okay, now I'm going to connect it. So what I have to do, I have to keep my cursor at the end and move this cursor. It is a wire, this is a wire, and connect it. If I connect it, you can see a cross symbol. This indicates it will be incorrect. Okay, it will be incorrect option. Okay, this cross symbol denotes incorrect option. So what we are going to do, this constant is not acceptable, so immediately you have to select and press delete button. Now anyway I'm going to create an output, so right click your output and create control. Okay, create control. Now connect it. It won't connect. Okay, it won't connect. These are the options. Okay, so again go to plus symbol, right click, create indicator. Okay, indicator means that is the output which we are getting, because in outputs there are three values are there. One is constant, control, another one is indicator. This indicators you have to create it. When you click the indicator, here you see the label x plus y. The x plus y is the formula for arithmetic. Okay, so now what I'm going to give, x value I'm going to set 1. How to set it means, I have to keep my cursor at 0, double click it, it will be display in black color. Now click 1, that's all. Then I can go to 0, double click it, type 2. Okay, type 2. Now you have to save this file. Go to file, save as. Okay, go to file, save as, and create, you can type program 1. Okay, program 1, and this file will be saved in terms of VLS VIL. Okay, option. Okay, .vi only it will be saving. VI means virtual instrumentation. VI stands for virtual instrumentation. Now I am going to run this file. So how to run? You see the arrow mark? There is a run option. In the top, there is a run option will be there. Okay, this option you have to press. Once I press this option, I can get an output in the front panel. You see here, front panel. So how much output inputs I am giving? 1, 2. It will be display 3. Okay, it will be display 3. Are you understand? Are you understand or not? This is a simple program in LabVIEW. Okay, in LabVIEW, arithmetic operation 3. Okay, so in the similar way, I'm going to explain so how to change this input value. Okay, I have to explain how to change this input value. So what I'm going to do, this is one program, the program number 2. You go to 2 and delete this option. This wires is also be deleted. Okay, deleted. And now in input 2, create control. Create control. See, if I create control, it will display in front panel because the input will be directly proportional to output. Okay, based upon the input, for every second the output value will be vary. So now I am pressing, okay, just run option. Here you see x value here 1, but y value it is 0. Okay, now in y, in front panel, I'm going to give 1. Okay, if I give 1, then press play button. If I press play, x is 1, y is 1, then see, x plus y should be 2. X plus y should be 2. Okay, then you want to run the program continuously. So how to run the program means, this is a run option, then you have to press run continuously. Okay, you have to press run continuously. If I press this run continuously button, okay, button, you see everything will be disabled, because the reason is that the program is running continuously. For every second it is running. Now we want to change the program when the file will be running it. So here I am going to change, see, 2. If I change 2, immediately it will be changing 3, because x is 1, y is 3, then x plus 1, 1 plus 3, 4. Okay, like that you can change it. You don't have to press run button every time. Okay, now if I want to stop this run continuously, there is a option abort execution. Abort execution means it should be a stop button. Stop. Okay, so this is the stop button you have to press. Okay, this is program number 2. Okay, now program number 3 will be again create, go to multiply symbol. Okay, go to multiply symbol, and maybe it will be a you can say it will be a AND gate or OR gate, whatever it may be. Okay, logic gates you can create it, and better in the multiply symbol, create control, because 2 control values I'm going to create it, because I'm going to change both x and y for every second. X value output indicator. Okay, so this arithmetic operation which denotes x into I. Okay, x into y, x into y. Now again please save this file, then you can put save as, because save as means we can save this file for experiment number 3. Okay, now press run continuously. If I press run continuously, both x and y should be 0. So 0 into 0, 0. Now I am giving 1. X is 1. You see 0. Y is 1. Then I am getting 1. And x is 2. Y is 1. Then it should be 2. And x is 3. Y is 1. It should be 3. Okay, like that. This is nothing but a logic gates which we are using in our digital systems. Okay, logic gates you can use it for arithmetic operations. Now if I want to stop this program, I have to click abort execution. I have to click abort execution. Okay, any doubts till now? Any doubts, students? Students, any doubts? Anyone? Okay.
No, sir.
Okay, okay. You see here, whatever the blocks which is available in our lab view, everything will be a graphical. Okay, it will be a graphic. It should be in very colorful manner. By seeing this colorful tools itself, everybody will learn this software, because it is not like a MATLAB or any other software. It's not like black and white color. It should be a very colorful manner we can use. Okay, as well as this software is very comfortable for learners, okay, to interconnect with our hardware. Okay, now delete this file. Now another program, we'll explain this one. I will explain how to create a signal. Okay, how to create a signal. There are different types of signals are there. Okay, you see here there are different types of signals. Signal processing. Okay, because whatever the concepts which you are studying in our engineering term, everything which is available here. Okay, everything which is available. Okay, waveform generation. Okay, just this is function generator which we are seeing in our laboratory. Okay, function generator, a big box will be there, but here it is just a small box. Function generator and sine waveform. Okay, now I'm click yes, sine waveform. Okay, this is a sine waveform. Now for the sine waveform I'm going to create an input. Okay, you see here. Okay, now this sine waveform, it's nothing but it is a amplitude as well as a frequency we need. Okay, in sine waveform, if I keep my cursor in the top layer, if I move this cursor to the top layer of this particular icon, okay, particular sine waveform, and I can get all the pins. How many pins are there? 1 2 3 4 5 6 7 8 9. But whatever the pins will be is required, okay, that pins will be enabled in orange color. Okay, this pin will be the frequency. Okay, create constant. So frequency will be 50 hertz, we can give 50 hertz. Then amplitude means y axis. Okay, create indicator, you can create an indicator. Sorry, okay, so this option it's not applicable for this particular window, because whenever you are taking, you can take any type of controller, indicator or whatever it may be, but if the wires not connected, the particular block not considering it. That is a meaning. So you can put control. Yeah, I can put control. Okay, you see here control I can put, that is for amplitude. When I click control, immediately it will display in front panel, because constant it won't display here. Okay, constant it won't display, only amplitude only, that is control only it will be displayed. Then phase value, it will be that phase value we can't give. And output side, signal out, this one right hand side, left hand sides are input, right hand side is output, signal out. Right click, create we can create a waveform, because I want to see the waveform. So the waveform blocks you have to get it from front panel, because that is the output display indicators. So go to front panel, right click it, right click, there are different types of options are there. Okay, I can click this indicator. Okay, for instead of amplitude I can take this one, this indicator. Okay, knob button I can take, I can remove this amplitude. Okay, constant parameters I can remove, and because this is for your understanding only I'm doing it. Okay, knob button I can use. Okay, indicators, and then right click, and here you see graph. This is nothing but CROs which is available in our laboratories. CROs. Okay, waveform chart, waveform graph. I'm clicking the waveform graph. Okay, this is the CRO display. Okay, cathode ray oscilloscope, time versus amplitude. Okay, this is one channel CRO. Okay, one channel CRO. Now I am connecting to signal out. See here, when I connect it, it will be in brown color. Okay, so the whatever the blocks which you are taking from front panel, that it will display in brown color. Understood? Now I want to change this amplitude, because I'm going to give, I want to change 100, I have to give 100-volt amplitude. Okay, and if you want to change this label also, I can change amplitude. Okay, I can change this amplitude, and if you want to zoom also, I can zoom it. Understand? So I can zoom, and you can move this window also, both top and bottom you can move. Okay, I can move. So here, okay, now I'm going to save this button, save, then press run option. If I press run option, I can see the waveform, but the waveform is, it's not visible. You see here, the waveforms not visible. So what I'm going to do, I'm going to select and drag this one. Okay, this is the waveform. Okay, now I have to give an input. So for that I have to change, give run continuously. If I click run continuously, now your waveform should be 0. Now I am going to vary. Slowly I can vary. You can see the waveform. Okay, so based on the my movement, it will be vary. That is knob button. Understand or not? Understand or not? So this is the purpose of capturing the waveform in sine wave, because in our laboratory we are using the CROs to connect with the what is that, cables, everything else. Sometimes the cable not working properly, but here in LabVIEW all the blocks are inbuilt. Just we have to select and we have to drag it. Okay, and one more item, you want to change the time. If you want change the time, I can change 0.1. I can change it. Okay, that is how to change means about execution 0.1. See here, if I change, if I increase my time, okay, y-axis, I can get the sinusoidal waveform in a properly. So how much amplitude I have given here? How much amplitude? Here it is. Wait. Here 0.1 I can give. Okay. Now I'm presses. I'm giving 50. I will give 50. Then run option. Okay. It is 1. Now 0.1. You see here, for 50 I'm getting a pure sinusoidal waveform. How many cycles are there? Okay, how many cycles are there? 1, 2, 3, 4, 5 cycles. I can get 5 cycles. Okay, this is the procedure. Okay, this is the procedure. You have to capture a sinusoidal waveform. Okay, sinusoidal waveform. Okay, now I want to see my window. Go to window, left right option. If I click left right option, I can get this both front panel and block diagram. Okay, any doubts? Any doubts?
No, sir.
Okay, okay. This is a single channel CRO. Okay, now you want to connect with multi-channel CRO, that is dual channel CRO means. So how many sine waveforms you need? 2 sine waveforms. Okay, again go to signal processing, then signal, say waveform generation, click sine waveform. Okay, you click sine waveform, and I need only one CRO, but it should be 2 channel. So what I'm going to do, again frequency 50 Hertz, create frequency constant, because frequency is 50 Hertz. You can give, and amplitude you can give it to some sorry, it's not indicator, it is control. Create control. Okay, you can give control. Understand? So I'm going to connect this second waveform to my CRO. Okay, it's not connecting it. Okay, it's not connecting. There is a issue will be there. Okay, it's not connecting it directly. Okay, so for that we have to create an additional channel. Okay, we have to create an additional channel. So for that, create, here there will be option, create, go to waveform chart. Okay, waveform chart. Yeah, it's a waveform chart. This one we can connect it, and this one also we can neglect. Yeah, it's not connecting it. Okay, it's not connecting it. So you need one more channel, we have to connect it. Okay, that I will explain it now. Okay, this is a waveform chart which I am selecting, but this is not, it not showing any grid lines, but it will be look good. Okay, press run option, I can get an image like, okay, it is not clear. Okay, I can improve one and press run option, it's not clear. The reason is that this waveform chart, it's not which is not properly connected, sorry, which is not connected with the hardware setup. Okay, the waveform chart, why we are getting this here white lines, some of the white lines means it's not connected with the hardware setup. Okay, so for better you have to remove. Okay, you should remove. Okay, you should remove. Then again please go to button and please click waveform graph. For second graph also click waveform graph and connect it, and connect it. Okay, okay, but here there are two windows or two waveform graphs are there. If I press the waveform, I can get two waveform graphs. Okay, but I don't want this two waveform graphs. So for that I'm going to arithmetic operation, click click plus symbol. Okay, you can click plus symbol, plus symbol, signal out, signal out. The one CRO waveform, one sine waveform is connected to arithmetic, another sine waveform output connected to signal out. The output of plus is connected to waveform. Okay, understand or not? If I connect it like this, then press running option. Running option. You see here, I can track this window. Press running option. See, the waveform, it should be very, because there are two waveforms are there at a time. Okay, there are two waveforms are there at a time, so I can put 0.01, it's more clear. Okay, 0.1, 0.1 I can get it. Okay, this both the waveforms are in same phase. Okay, that's what we are getting, more thick lines. Okay, so this is the method to connect with this waveforms. Okay, with one CRO by using two channels, by using two channels. Okay, next program. Okay, this is another program. Okay, and this is a loop. Understood? This is a loop which I'm going to create it. Okay, so this loop where it is available means here in programming I'm clicking a loop statement. Okay, loop statement, and I'm selecting the waveform generation, and this waveform generation I have given input called frequency amplitude. Frequency amplitude means this blocks I can take it from here, this one, this blocks. See, icons are same, but the notations, that is labels which you are giving for everything it is different. That is based upon our available applicability for our program that we have to decide. Okay, frequency, amplitude, and a signal type you have to give, whether it will be a sine waveform or trapezoidal or square or pulse waveform. Then waveform graph. Okay, waveform graph you have to create. Now press run button. Okay, I can't get the waveform here. Y means both the frequency amplitudes are 0. Okay, but I'm click sine waveform, but it is both are 0. Now I am giving amplitude to 2, then frequency 2. Okay, frequency 2. So if I give frequency 2 and amplitude 2, I can get the waveform continuously. This is the sine waveform. If I want to stop, I can click stop button. Okay, I can click the stop button. This is a small program. Now I'm going to change this waveform. Okay, when the program it is in running. Okay, so how to change? Click run continuously, then go to icon here and please click change sawtooth button and click stop. It can't stop. Okay, it can't stop. Understand? This is the sawtooth waveform. Now if I want to change this square waveform, okay, it is running, and press stop button. Okay, stop. Actually there is a doubt. Okay, why we need this loop statements? Actually loop statements will be applicable for a particular programming for in terms of running conditions. Without clicking the run continuously button, I can't click the run continuously. This is the loop. In that loop I have created a particular program. The program is executing in a proper manner, and the program, whenever the customer or person will be need the program to stop without disturbing the effective parameters, we have to click this stop button. Okay, this is square. Now I am going to change it. It is triangular waveform I need. Now I am pressing run option. See, it is continuously, it is running. Okay, now press stop button. This is triangle waveform. Okay, so in this manner you have to do. And if I want to change the frequencies value, I can change here 50. You can change 50, and amplitude you can give 20. Okay, then change the waveform. Sine waveform you can change and click run option. It is running. Now I want to stop. You see, this is the waveform. Understand? You understand my point? And when you click the loop statements, you see here how to create the loop means go to functions, and there will be a loop buttons are there. Okay, this is for loop, this is while loop, this one is timed structures, and this one is case structures. Because those students studied C program, they know about the loop statements properly. Okay, now I'm creating a for loop. This is a for loop. Okay, this is a for loop which I am going to create it. Okay, this loop only which is available. Understand? Understand? And another one also, here it will be a flat sequence structure or while loop also you can create. This is while loop. This is while loop. And you need stop button. So how to create, how to do this program means the first step, right click it, go to structures, and please click while loop and keep the cursor here, select and drag. You will get this window. Okay, you will get this window. Then you have to go to this option and create in signal generation, waveform generation, sine waveform. Okay, and this frequency amplitude we have to take it from front panel. These icons you have to take. Understand? Frequency. And if you want to change the label, you can change it. This is frequency. Okay, this is frequency. Like that we have to do. And without stopping option also you can run. But how to stop this waveform without disturbing my icon? Okay, so for that purpose I need, because if you take your CRO also, there is a stop buttons are available in our machine. Whenever if you want to capture the waveform, you have to press the pause button or stop button, then only you can capture the waveform in a proper manner. Like that, here also there are stop buttons are available that we have to open it. Then another program, third program, it is this one will be, it is a Boolean algebra. This is a Boolean algebra which I have done for the students in terms of a mini project. This is a Boolean algebra which we are executing a tank, water level tank. I am giving a delay, and this is the loop statement. So this is the loop which we are executing it. Okay, and this is a water level, and you see the tank, the water level will be controlled based upon this algebraic value which we are giving it. Okay, like that, because whatever the programming or whatever the, for example, you are doing a mini project, small mini project, okay, logic gates or VA characteristics, like that, small program that you can do it in LabVIEW. Okay, but some exercise you need. Exercise means in terms of some homework you need in terms of technical point of view. Okay, then go to file. Another program I will show. This program called it as a small addition and subtraction option. Okay, this I already done. Okay, this I already explained it. And this addition, I am taking the variable control indicators, and for minus also I am taking control indicators. Okay, and for both the indicators we am going to measure. For arithmetic it should be a plus b, and for this subtraction they need a minus b. For a minus b I am taking the inputs from a plus b only, which I am taking, and the program will be executed. You see here a 1 plus 1. Okay, and I'm giving input a11, a plus b is 2, a minus b will be 3. A minus b will be 3. Okay, like this we have to do. Any doubts? Any doubts? Anyway, this all these programs will be shared. Okay, the materials will be shared to you people. Okay, that another program. How to convert the Celsius to Fahrenheit. Okay, Fahrenheit in terms of thermometers. This thermometer symbol I am taking from here. Here, thermometers are available. You just take this thermometer which is available here. If I take this thermometers here, it will be displayed here. You see, everything, both front panel and block diagram are interconnected with each other. It will be integrated with each other. So to convert Celsius to Fahrenheit, I need a thermometer, that is my output, but I need a formula to convert it. So how to convert? It will be, I need a Celsius. Okay, Celsius will be multiplied with 1.8. Okay, Celsius will be multiplied with 1.8, and this 1 point, whatever the output which we are getting, it will be given to the 32 degree, and it should be plus. Okay, that is a formula. So I am giving a plus symbol and Celsius. I am giving 3 Celsius. See here, I am clicking run continuously. I am changing the value of Celsius. My thermometer value will be changing. My thermometer value will be changing continuously. So based upon the Celsius, the parameters will be changed. Okay, it should be changed. Okay, so this is the method which we are going to write. ಮುಂದೆ slower ಬರ್ಸು. The Celsius will be, I am giving 49 degrees. This 49 degrees is the input which we are given, and it will be converted into thermometer range. Okay, you see here, it will be changing, right? You see, based upon my Celsius it will be changing. When this thermometer value will be changed, it is basically depends upon this run continuously button. If I press run continuously button, then only I can change. Otherwise, for every time you have to go to run button and you have to press it. Any doubts? This is the run continuously. Okay, this program I will explain it again to you people. And right click this button, thermometer, and here it is multiply symbol, and for to convert this thermometer the Celsius value, it will be, we need indicator, control values, then here it is create constant, formula is 1.8, and the parameter here it is plus, and the output of this X will be connected to an this one and a plus symbol, and this Y will be a constant. It should be 32 as per the formula, conversion of Celsius to Fahrenheit. And this Y parameter, X plus Y, will be giving to thermometer, but I can't get the thermometer in block diagram. I'm going to get the thermometer only in front panel. Go to front panel and please select this thermometer, and here you got this icon, then connect it. Okay, then connect it. You see here it is connecting it. When I drag this a particular thermometer icon, I can able to see my wire is properly connected. Okay, this is the way you have to check. Okay, and you can change the label also of X. It is Celsius, CELSIUS, SIUS. I can change. Now press run button. Okay, this value I will delete it. This program delete. Okay, I got Celsius value. Now press run continuously. Change this thermometer. I am giving 5. The thermometer value goes to 50 temperature. Okay, so like this we have to execute this program. Okay, and another program, and it will be called thermocouple show. Okay, left right button. Okay, so this is the thermocouple. This is the DAC assistant card which we are using, and because this DAC is nothing but a data acquisition card which will be connected with hardware versus software, which will be connecting it. And I press run option, but I can't get this DAC access. The reason is that this DAC accessment card which is connected with the hardware. Okay, that's what you are getting this error. Okay, if I, for example, there is a motor will be there. Now I am going to measure the temperature of the motor. Okay, so I have to connect this DAC card by using a wire. It should be connected with the motor, then only this icon will be enabled. Okay, icon will be enabled, otherwise you will get this window like this. Okay, it won't run. Okay, so this is a method to connect with the hardware. We need DAC assistant, okay, which is available in the software itself, but hardware modules are there. But one DAC assistant, it comes around 1.1 lakhs. It comes around 1.1 lakhs. And another program, this is a measurement of transients. to measure the transition measurement. It is like waveform. It is a waveform to measure. Okay, and this waveform we can measure it like what type of waveform it is, sine waveform, and frequency, and what is that undershoot time, overshoot, because these are the parameters which normally we are using measuring in a DSO, not in analog CROs. It will be DSO, digital storage oscilloscopes. It will be automatic display, but in our lab view we can create it. That is possibility will be available. Now press running option. You see the waveform is running continuously. I can able to see the all the parameter display. For every second it will display. Now I would like to change this waveform. I'm giving sawtooth waveform. I'm getting the waveform like this, but it will be a distortions are available because it is a real-time waveforms. The distortions are available because most of my research works it will be based on this LabVIEW only. I'm using only LabVIEW softwares for capturing the signals. Okay, and the square waveform. You see the square waveform. These are the real-time data. We can measure it. When you start as a student community, when you start this language, that is graphical programming language, in small experiment or in your laboratory, a mini project, then it will be more useful for you to execute the same thing to your main project. Okay, main project. But it is one of the fantastic tool to showcase your project. Okay, to showcase your project. Okay, I will show my research in this particular field. I'll show the file to you people. Some of the files which I'm having it. Yeah. It will be LabVIEW workout files. That's right. And wait 1 second. And this is a file which we are doing for this research, in the research, to measure the noise ratios. Okay, to measure the noise reductions which we are executing it. And when you write the program, it will be like, it will be, you don't see this blocks. Okay, because blocks are very simple, but whatever the steps which we are executing it, all the steps are available step by step. Step by step you can connect and you can do the program. I will show the motor, how we are generating, executing the motor. Some of the files not working. Okay, this is a file. And this is a sine waveform. Okay, this is a sine waveform. You see the block. Okay, this is a front panel. A small windows are there. You see these are the windows are there. But when you go to the this file will be somewhat complicated, because you have to draw the waveforms properly. Okay, You have to select the blocks. Everything I'm using only arithmetic operations only. I'm using arithmetic operations. So here I'm just pressing the running option. You see here the waveforms are moving. Now I'm going to change these variables. The phasor diagram. This is my phasor diagram. You see the phasor diagram. Whatever the phasor diagram which you are studied in your basic electrical engineering in terms of AC systems. Okay, you see this diagram based upon our signal. It will be more. Okay, the phasor diagram will be more based upon the movement of electrons. Understood? Okay. I will show the motor now. Some other one because it is updated, so I can't open the files properly. Just okay, this one. This is an example of a cluster. Okay, this block will be. It is available here. Understood? This is nothing but compound arithmetic option. I can add all these three at a time. One, one, one. Press this option. We will get three. Okay, like that we have to do. And I will explain what are the blocks are there in the front panels. There is a switches are there. We put in a push button switches are there, and in terms of string parameters and the data containers and list graphs are available, 3D plots and the rings are available, and here there will be a fuzzy logic is also be available. Fuzzy logic toolbox will be available. Okay, this is a spectral analysis. This is a spectral analysis graph. If I click this spectral analysis, I can get a waveform. You see here, this is a spectral analysis. And this is a spectral analysis graph. Okay, any doubts? Any doubts? And the main purpose of this course, we are just giving the idea about how to start the program or how to learn the particular software. Okay, that is a main agenda of our course. Okay, so I will share this some of the files to your registered mail IDs, because I'm going to share the attendance link to your in the chat box. And please give your attendance and give your mail IDs properly, and name, everything. Your name should be in capital letters, because whatever the name will be you are putting, that name only printed in your certificate, and the college name you should give properly. Okay, if there will be external candidates are there, please give the college name properly and a mobile number also. We'll share the certificates to your Gmail IDs. Okay, thank you. And you can use this if you have any doubts. Any doubts, students? Have any doubts?
No, sir.
Okay, okay.